everyone. So this is the last section of our equilibrium video. So this is part 4B. I guess I thought I could cover all 4 of them in one video, but I decided to split it up. It's a lot of material this week. All right, so in the last video, this is where we ended. We were talking about the equilibrium shift if there is some sort of change in temperature. So now let's talk about the next one, which is going to be a change in pressure. All right, so if you guys remember how we're going to deal with a change in pressure, we are going to change the volume. If you guys remember about Boyle's law, once we decrease pressure, it ends up increasing volume. Remember, whatever we do to one, the opposite happens to the other. In this situation, when we're talking about pressure, it is only going to deal with gases. All right, so please keep that in mind when you're looking at your equation. So the rule that you need to remember is that if we are decreasing volume, right? Think about it this way. We're decreasing volume. That means that there is less space in our system for there to be any gases. So basically what you need to remember is that when we are decreasing volume, that equilibrium is going to move toward that should say side, apparently I can't spell today, is going to move toward the side that has the least amount of moles. So if you remember, when we're looking at an equation, we're looking at the same equation that we were looking at for the other 2 problems. When you're reading this, right, it says 1 mole of nitrogen plus 3 moles of hydrogen yields 2 moles of ammonia. So as you're looking at this, on the reactant side, you should see that there are 1 plus 3, so that means there are 4 moles on the reactant side. On the product side, there are just the 2 moles of ammonia, so it's 4 moles versus the 2 moles of ammonia on the product side. So what this means is if I end up decreasing volume, the equilibrium is going to move, or the reaction is going to shift toward the side that has the least amount of moles. Okay, so let's go through it. Volume change. We have decreased the volume, aka we have increased the pressure. What's going to happen is that because we've decreased the volume, there is less space for the gas to float around in. So to minimize or reduce the stress on the system, that means that the reaction is going to shift toward the side that produces the least amount of moles because you don't have as much space. So if I have 4 moles versus 2 moles, the reaction is going to shift toward the product side because the product side has 2 moles while the reactant side has 4 moles. In the other situation, if I increase volume, aka a decrease in pressure, but I'm increasing volume, which means that there is tons of space. And because there is tons of space, the reaction is going to shift toward the side that has the most amount of moles. Okay? So if you take a look once again at our equation, it's still the same 4 moles and 2 moles. Because we are increasing the volume means that we have more space. The reaction is going to shift to basically increase the amount that it's creating. To do that, it's going to shift toward the reactant side because on the reactant side, you create 4 moles to the product side where you only create 2 moles. Okay, so those are the answers to the questions on your note sheet. So if you were to decrease the volume or increase pressure, right? It's both the same thing, Boyle's law. Once you do something, once you decrease one, the opposite happens to the other. So we decrease the volume, we have less space for these moles of gas to basically hang out in. So what it's going to do is to alleviate the stress on the system, it's going to shift to the side that has the least amount of moles, right? It'll take up the least amount of space and reduce the stress on the system. So it's going to shift toward the product side because there are 2 moles on this side while there are 4 moles on the reactant side. On the other hand, if we increase the volume, aka decrease the pressure, there is more space for the gas molecules to hang out in. So the reaction is going to shift toward the side that creates the most moles because now I have the space for those extra moles. So in this equation, it's going to shift toward the reactant side because there are 4 moles on the reactant side versus 2 moles on the product side. I hope that that makes sense. The fourth stressor is probably the easiest one of the bunch because guess what? Anytime we add a catalyst, the catalyst has absolutely no effect on equilibrium. All the catalyst does is speed up the reaction. Okay, so that's all you need to know is the catalyst is going to speed up the reaction, has no effect on equilibrium. Okay, so the last part of your notes is basically a summary, and this is to see if you guys know what is going on. So my advice to you is I would hit pause and stop the video, and then go through each of these, and then check your answers with me at the end of this video. Okay, so go ahead and do that. All right, so I'm going to go through what the answers of these are. So here's the deal. We have essentially 3 stressors that you need to fill out a chart for, right? Because if you remember, the fourth one is a catalyst, and a catalyst has nothing to do with equilibrium, it just speeds up the reaction. So what I want to go through first are the changes in concentration. So if you have changes in concentration and your reactants are added, what's going to happen is the system is going to want to get rid of the reactants and use them to create products. So your reaction is going to shift toward the product side. On the flip side, if you have reactants that are removed from the system is going to want to replace those reactants. So it's going to shift toward the reactant side to make more reactants to replace what was removed. Hopefully that makes sense now. The third, products are added. If products are added, the system is going to try and reduce the stress by getting rid of the extra products and making reactants. So that means that it's going to shift toward the reactant side and use up the products that were added to the system. And then on the other side, if the products are removed, then that means the system is going to want to replace the products that were removed. So the equation is going to shift toward the product side. Hopefully that makes sense for changes in concentration. For the second, which is changes in volume, remember that's going to affect the pressure. If you increase the volume, which means a decrease in pressure, that basically means that we're increasing the volume. That means that the system has more space to create as many moles of a substance it wants to. So it's going to shift to the side that has the most moles because the system has the space to accommodate those moles. The second situation is a decrease in volume, which is going to be an increase in pressure. Now we're reducing the amount of space that those gas moles have to navigate. So in order to get rid of the stress on the system, it's going to want to produce the least amount of material. So it's going to shift to the side that has the least amount of moles. In terms of change in temperature, what you need to realize is whether the heat or the reaction is exothermic or endothermic. That's going to determine which way the equation or the system is going to shift. So if you have a temperature increase in an exothermic reaction, so remember an exothermic reaction means that it releases heat. So if it releases heat, it's going to end up on the product side of your equation. So if we increase the temperature and it's an exothermic reaction, the system's going to want to try and get rid of that excess heat. So it's going to shift basically to the reactant side that does not have the heat on it. On the flip side, if we increase the temperature and it's an endothermic reaction, remember, endothermic, it is going to require heat. That means that you need heat on the reactant side for the reaction to happen. So if I increase the temperature and it is an endothermic reaction, the system is going to want to find a way to get rid of that heat. And to do that, it's going to shift toward the product because the product side does not generate any heat. And then the last two, if you decrease the temperature and it is an exothermic reaction. So remember, exothermic releases energy or releases heat, which means the heat will be on the product side. So if I decrease the temperature, the system is going to want to replace the heat that I have taken away. To do that, because the heat is being generated on the product side, because it's exothermic, that means the reaction is going to shift toward the product side that creates the heat. And then on the other side, if I increase the temperature and it is endothermic, right? So now I have increased the temperature and it is endothermic. And actually, I think that's supposed to be decreased temperature. Hold on, let me check your notes and make sure. Yes, I don't know what my brain was thinking. So here we go. We'll change it right now. So if we are decreasing the temperature, okay, so with a temperature decrease and it's endothermic, remember that endothermic is going to have heat on the reactant side. Remember, it's necessary for the heat for the reaction to happen. Like there has to be heat for the reaction to occur. So if I decrease the temperature, the system is going to want to replace the heat. The only side of the equation that generates heat is going to be the reactant side. It's going to shift toward the reactant side, okay? So the only way that I know how to do these problems is basically to say them out loud. So if that helps you, I hope it does. I'm going to post up the answers right now, which are actually on the other half of the slide. So please make sure that you know what you're doing when it comes to Le Chatelier's principle. Make sure that you know what the 4 stressors are and how they affect the system. And hopefully if you guys made it through this chart or this table, you guys should be experts now on equilibrium, Le Chatelier's principle, and how stress affects a system. All right, guys, that's it. If you have any other questions, please feel free to hit me up on Teams or Remind, and we'll see if we can get them sorted out. All right, guys, bye.